Hey guys, welcome back to another video in my series of Oxford videos. This is for those of you that want to study engineering science. I studied engineering science at Oxford, specializing in mechanical engineering in my master's year. And so if you're thinking about applying, here's a little breakdown of the course from my experience. So the course is called Engineering Science, and the first question is, why is it not called mechanical or electrical engineering? It's because in the first 2 years, it's a very general course. So for the first 2 years, you study a wide variety of topics within all of engineering and then specialize in your third and fourth year. So in the first year, it's called the P year. You have P1, P2, P3, P4, and P5. So P1 is mathematics. Here the topics are calculus, ordinary differential equations, linear algebra, just to name a few. The second P2 module is on electrical and information engineering. Here you look at circuits, electronics, signals and systems, and other things. Then we have P3, structures and mechanics. Here you look at statics, dynamics, stress and strain, along with other things. And then finally we have P4, which is energy and thermal fluids, which is thermodynamics, fluid mechanics, and heat transfer. Finally, you have P5, which is practical applications of the first 4 modules. So you go into a lab once a week and you implement things you learned from P1 through to P4 in the real world. So that's the P year, the preliminary year. And then after that, you have your internal assessments, from which then the university picks whether you're staying or whether you are dropping out. So not everyone passes that first year. It's a year where you learn a wide variety of engineering topics, and then they assess you and see if you're ready for the next year, because the next year is more of the same thing. So in the next year, you have your A modules, which are again A1 through to A5, focusing on the same thing. So A1 is mathematics, A2 is electronic and information engineering, A3 is structures and mechanics, A4 is energy and thermal fluids, and then A5 is also practical. But the stuff here gets much harder if first year wasn't already hard enough. So first year is tough. You learn a lot of stuff. It's your first introduction to higher academia, to learning things that are not on a school level, reading your own books, doing a lot of self-study. It's very difficult. And so the preliminary exams are there to just make sure that you are ready for that second year where things get even more harder. It's just a kind of linear trajectory of difficulty throughout these first 2 years. But essentially that second year is just a continuation of stuff from the first year, just a little bit more advanced. And so you might be thinking, okay, it's just these preliminary exams that are assessed, but throughout the entire year, you have these things called tutorials. So for every set of 8 lectures, you have 1 tutorial sheet. And so you have your lecture set, and then you get a big block of questions. That's kind of like your homework. It's called a tutorial sheet. They usually have 10 to 12 questions that are super difficult. They get near enough impossible by the end, and these take a lot of time. And so that's kind of your homework, and you work through those in your spare time. And then you meet up with a professor for each tutorial sheet and go through it for about an hour or 2 with just you and the professor, or you and another student and a professor. So they are super intense. You have to make sure that these are done to the best of your ability, because you get grilled by these professors. So those tutorial sheets take about 20, sometimes even more hours, and you probably have 2 or 3 in a single week. So the workload is insane in those first 2 years. Once you've done that second year, again, you have exams. So you've had your tutorial sheets throughout the year, and then you have a big block of four big exams, and the 5th A5 module is just assessed throughout the year, like some sort of coursework. Once you've passed that second year, you then move on to year 3. So one good thing about the first 2 years is everyone in engineering is doing the exact same modules. You're all going to lectures together, you're struggling together, you're working together. And then in the third year, you're kind of left to your own devices. You pick some modules by yourself. There's also some compulsory modules that you have to do, but most of the modules you do are completely up to you. After those first 2 years, the reason why you can pick any single module is because those 2 years are so intense that they prepare you for everything. You have all the tools that you now need to be a good engineer and to then apply them to further learning in your third and fourth years. So the third year is where you finally get to specialize. You have some mandatory modules, for example, B1, so second year is called A, third year is called the B year. So you have your B1, which is a computational module. It is essentially another piece of coursework. it is a computational project. So throughout your first and second year, you'll do some coding, and then in your third year, you have this piece of coursework that you're meant to code up in MATLAB. The software is called MATLAB. It's very similar to Python. And to prepare for this coding project, you work through a few lectures on finite element analysis, optimization, or numerical algorithms, and you implement this in a project of your choice. So for example, I used optimization within aerodynamics, designing an aerofoil and optimizing it to a specific set of criteria. Another mandatory module is the B2 module, which I personally loved. It's finally a piece of work that is not just in numbers. It looks at engineering ethics, it looks at project financing, it looks at teamwork and project management. And the lecturers here are super interesting. They come from industry as well, and they teach you how engineering is actually done in the real world. That was probably one of my favorite modules of all. And yeah, so that's great. Then you have your B3, which is your first piece of project work. And here they want to see how you work in a team. So there's 5 or 6 of you. You choose a project from a list. It is a complete design of something. And in my case, it was a complete design of a system to make fake chicken meat. In these projects, they're super vague, and so you can go into as much detail, but they essentially want you to focus on how do you look at academic literature, picking a specific field that you want to focus on. I tried including my interest in mechanics and applying it to different processes of how we were to come up with this final design of an actual factory that was going to make fake chicken meat. We had a super detailed design. That is a project alongside your other modules that you have to work on and then submit as a big project at the end of the year as well. So then you have these 3 mandatory modules. You have your B1 computational project, B2 engineering ethics, sustainability, project financing, etc. And you have your B3, your group project. And then you're left with 5 modules that you can choose by yourself. And this can be from any aspect of engineering. There's a long list. You can focus on mechanical engineering, you can focus on civil engineering, you can go into aeronautical engineering. What I picked was what I found interesting at that point. So I had some courses in chemical engineering, some courses in mechanical engineering, and some courses in biomedical engineering. Basically trying to make my major mechanical engineering while also implementing things that I found interesting. And then finally, there's a lot of exams in this year. So for each of those 5 modules that you picked, you have an exam at the end of the year. Obviously, you also have tutorials throughout the year. So same sort of workload from previous years with the tutorials, but then again, final exam at the end of the year. But here you have those coursework modules. So the computational project and the team project, there's no final exam. They're just marked as big projects at the end of the year, which is great because it spreads the workload. But then also your grade doesn't rely on just a single exam, it relies on the overall work you did. So here, some people are really good at exams, really good at studying, and so it's easier for them to just have a single exam. Whereas for the project, it really shows how much work you've done at the end of the year based on what you submitted. So a bit of a mix here of coursework and then actual exams. And then finally we get to the final and 4th year if you choose to stay. So you don't have to stay for the 4th year. You can leave after 3 years with a bachelor's degree in engineering in the specific field that you sort of majored in, or you can stay for that 4th year. And I decided to stay for the 4th year because of that final master's thesis. It's a project where it's a personal project, so just you under the supervision of a single professor, and it's pretty much whatever you want to do, which I found super interesting. So I definitely wanted to stay on for that year, and I ended up with a really great supervisor. And for most of the year, I was stuck in the bottom of the engineering department in the thermodynamics lab, focusing on characterizing fire tornadoes. So my thesis was pretty much, I wanted to develop a software which firefighters could use, not with some thermal imaging cameras or anything else. It was just a simple iPhone software where they could take a picture of any wildfire and sort of find metrics to assess the danger of that fire, whether it's coming towards them, going away from them, and more specifically in terms of the cases where the flames are rotating, where fires are much more unpredictable and dangerous. And this takes up a lot of time, getting the readings, doing experiments, figuring out what you actually want to look at, because it is again super vague, and so you have to kind of form your own project. You have to form your own project along the way under the supervision of a professor. So it's weekly meetings with the professor, it's tons of hours in the lab, And this probably takes up half of the year just getting everything perfect, and then you have to write it out in a big, I think it was a 40-page document of everything, and that is your master's thesis. But then again, alongside this, you also have 6 more modules which you take, which are then assessed in a final exam. So for my 6 modules, I did sustainable energy, environmental engineering, hydraulics, aerothermal engineering, and cellular engineering and therapy. So again, a very wide range of subjects, some of which I just chose because they looked interesting, but also trying to keep my major in mechanical engineering and thermal fluids. So here in that 4th year, you have your coursework module, which is your master's thesis, and then you have these final exams, 6 exams at the end of the year. Not to say all of the tutorial sheets that you have to do throughout the year for these 6 modules. And after all that, if you pass everything, you are then a graduate Oxford engineer. So yeah, super summarized video of what my courses and modules were. Obviously, I didn't mention sort of percentages based on the grades. So for example, in the final year, I think it's half the grade was the master's thesis and half the grade was the final exams. For other years, in the first 2 years, you have just exams, so they're sort of spread quite equally. And then in the 3rd year, you have the team project taking up a specific amount of the final grade, etc., etc. But basically the grades are, your first year doesn't count to your final grade. It's just to check if you are ready to carry on. And then from the 2nd year to the 4th year, all of these exams and coursework sort of tie up into your final grade. It's a tricky system, but whilst you're in it, you don't need to really focus on percentages and stuff like that. You just have to do as much work as possible. And talking about workload, for the first 2 years, that workload is super intense. It's not that the workload decreases, it just becomes a lot more varied. So you're not just sitting in the library doing your tutorial sheets, practicing exams, just doing a ton of maths and physics every day. You are actually going out to different labs. You're meeting with your project partners. The workload becomes much more interesting and varied, which I really enjoyed. But essentially, a super busy course, really interesting. I loved it. If you love engineering, then you will love the course. For the first 2 years, it is super general, so there will be some subjects you don't like, but it is essential that you do them because they make you a well-rounded engineer. So if you're interested, consider applying. If you have any more specific questions about the course or the workload or anything, just leave a comment down below and I'll reply to every single one. And yeah, I hope this video helped. Consider giving a like, a little subscribe, and I look forward to all your questions down below, and good luck with your application process. Bye.